Oh, hi everyone. So I'll be recording the very last video of the lesson series, and in this video we'll be talking about um, the zero product rule, which is a very important concept in any function field, and we're going to be looking at a couple problems that deal with zero product rule, and we'll come up with the solution at the end. So once again, we're just going to be reviewing the concept of zero product rule. So I'm just going to read out the definition that we have on the slide. So zero product property. So when the product of two or more numbers is zero, one of this number must be zero. It's known as the zero product property. If the two numbers are represented by A and B, this property can be written as follows. If A and B are two numbers where A times B equals 0, then A equals 0 or B equals 0. So for example, if we have two factor terms, 2x minus 3, and 2x minus 3 times x plus 5 equals 0, then either 2x minus 3 has to be 0 or x plus 5 has to be 0. And when we solve the solution, we get x equals 3 half or x equals negative 5. So this property helps us solve quadratic equation when the equation can be written as a product of factors. So I hope you guys remember from last time we learned how to factor quadratic equation. So when we have this kind of form, x squared, and that's 2 then, x squared plus 2x plus 1, and using the generic rectangle formula and the diamond method, I'm going to put 2 on the bottom and a 1 on the top, because A times C, and our A is 1, and our C is 1. And we'll have to find two numbers that gives us 1 when we multiply together, and 2 when we add together. And I was actually able to come up with two numbers pretty easily. It will be 1 and 1. So 1 times 1 equals just 1, and 1 plus 1 is 2. So we're going to go ahead and put 1 here on the side of the diamond, and this yields us the solution x plus 1, x plus 1. And what the zero product rule tells us is, what zero product rule tells us is, so when this equation is to be 0, we're going to have either x equals negative 1, and also for both cases, because when x equals negative 1, when we plug negative 1 value into the x, this gives us 0. So whatever times 0 is always 0. But of course, when we plug x equals 1 here, we also get 0. So using the zero product property and the factoring that we learned from last time, we'll be solving a couple problems. So some examples of using zero product rule. So we're going to go ahead and read the problem. The trajectory of the Gantt flight is a parabola, so we can describe its flight using the method of a quadratic function. We are going to describe the Gantt flight using the quadratic function. It's notated by h of t equals t squared minus 8t plus 12. H of t equals t squared minus 8t plus 12. So we're indicating the function in terms of t time and the height with respect to the time t. And they're saying the parabola or the Gantt flight, if you graph it, it's going to look like something this. So this is the height, or the y-axis is height with respect to t, and the x-axis will be t. So given our equation, t squared minus 8t plus 12, and let's go ahead read part A. It's asking how many seconds passed before the Gantt entered the water. So we are describing the Gantt flight as a parabola, and when it enters the water, that means the height of the Gantt flight will be 0. Why? Because that's where the water is. So we're looking for the part for a case when this equation, when that equation is 0. So what do we do? Last time I remember we talked about factors. So we're going to be splitting this term into 2 terms, which is not too hard. And before that, we're just going to identify the variables. A equals 1 because that's the value that's in front of t squared. B equals -8. C equals 12. C is at this value. So we know that on our diamond, we put A times C. A times C and a B value here, which is A times C is just simply 12. I'm just going to erase that and then put 12. And then B value is just -8. And then we're now going to look for 2 possible numbers that will give 12 when we multiply, -8 when we add it together. M and N are just any numbers. So what are 2 numbers that can give us 12 when we multiply and -8 when we add together? I think I already think of one. I think 6 and 12, 2. So 6 and 2 gives me 12 when we multiply, but then just be mindful because later on we want -8. So I'm going to put -6 and -2, which will still give us positive 12 because when you multiply 2 negative values, then we get positive value. And indeed, -6 plus -2 is -8. So we did find the 2 numbers that we can put on the side of the diamond. So now we can write that as t minus 6, t minus 2, which we're looking for the case when that equals 0. And we can simply see from the zero product rule, either t minus 6 has to be 0, or t minus 2 has to be 0. So there are 2 cases where t minus 6 is 0, which gives us t equals 6, and t minus 2 equals 0, which gives us t equals 2. So we have indeed found the case where the Gantt flight entered. Oh, this moves around. I don't know what to do with that. So I think I drew the function equation wrong because it should be open up instead of open downward, because it starts in the water and then, hold up. Okay, so it should look like this. So this is under the water. This is under the water. And the graph looks like this. So this is when it entered the water. This is when it entered the water, and this is when it came out of the water. So that's graphically makes sense because we know that we found the 2 values where t equals 2 and t equals 6. So we actually have found both values. So at t equals 2, it enters the water, and at t equals 6, it comes out of the water. And how long was the Gantt under the water for? Well, it's just a simple subtraction. If you think about it, at t times 2 seconds, it entered the water, and then at time 6, it came out of the water. So in total, it was only in the water for 6 minus 2, 4 seconds. Alright, continuing. So this part is, it requires a little bit more thinking. So it's part D is asking, what was the deepest dive of the gannets? So from the earlier part, we know the graph will look like something like this. Alright, and this is the time when it entered the water, and this is the time when it came out of the water. And it's asking what's the deepest dive of the gannet. And what's the concept? What's the deepest one? It's asking for the minimum height. Well, we know that we can find the minimum or the maximum of a point of a parabola, and it's called what? Vertex. So we are looking for the vertex point, which is located here. And cool thing about parabola, the vertex lies on the line of symmetry. So this is line of symmetry. And then hopefully you remember the equation. It's x equals negative p over 2a. And from the earlier, we know that function is t squared minus 8t plus 12. And when you plug all those values, well, b is negative 8, so I'm going to put minus 8, and I just want to match all the color, and plus 2 over 2a is just a is 1. So we have found negative times negative become positive, 8 over 2, 4. So it's saying at time 4, it reaches the deepest, right? So now we know the time. We're going to plug that in. What's the height at time 4? So we're going to plug this value t equals 4 into the original function, which is located here. And it's a simple, you just simply plug that value in, and it will be, let me just write it down really quick. 4 squared, negative 8. 4 plus 12 equals, sorry, this should be 4. 16 minus 32 plus 12. And that's a negative 4. So the deepest height is under the water, the 4 units, 4 feet below the water. That's part D. And after how many seconds was the gannet at its deepest? Well, we know that it was at time 4. We already found it. That's the answer. And, oops. Now what's the last part? After 7 seconds, the gannet burped and dropped its fish. At what height did this occur? So it's just asking, what's the height of the gannet at time 7? And it's a simple plug-in part again computation. I'll show you how to do it, but I'm not going to actually solve it out for you. So you would just simply be plugging time equals 7 into the equation, and you'll be able to find the height. Okay, since the video is getting long, I'm not going to go over step by step, but I'm just going to give you a general sketch of this problem, and then I'll try to put up the solution later on. Well, so let's read the problem first. Dimensions of a rectangle. The length of a rectangular flower bed is 2 feet longer than the width. If the area is 6 square feet, then what are the exact length and width? Also find the approximate dimensions of a rectangle to the nearest tenth of a foot. So we have a couple information in this problem. The length of a flower bed is 2 feet longer than width. Okay, so 2 feet longer than width. We don't know what the width is. And if the area is a 6 square feet, and we are looking for both length and width, okay? So how do we find the area of a rectangle? It's simply just length times width, right? So let's just go ahead and write down length times width. But I don't want two different variables, so I'm just going to substitute 2 plus w into L. Just because we want to stick with one variable. So when we write it, it will be just 2 plus w times w. So that's the area of a rectangle. And what's the value of the area of the rectangle in the problem? Yes, it's 6. Okay, so very easy. Very, very, very easy. So now we're going to try to change this form into a more familiar form, quadratic form. I'm going to first distribute this w into 2 plus w value. So it'll be what? 2w plus w squared still equals 6. And I'm just going to move the 6 value 6, into the same side over here. And then I'm just going to just write in a more familiar order. W squared plus 2w minus 6 equals 0. That's because I subtracted 6 on both sides, here and here. Here and here. So we have this, and you might not be able to find the two values for our diamond method. And what do we do when that happens? Yes, we usually use a quadratic formula. So we use a quadratic formula when we cannot find the two values for the side of the diamond, which I will put it right here. X equals negative b plus minus square root b squared minus 4ac over 2a. So now that I have even given you the formula, it'll be really easy to solve what's the length and what's the width of a rectangle. And this is just a general idea of using the quadratic equation, and using the zero product rule. So when we have set up the solution, or when we have set up this equation, what did we do? What we did was, after we set up the equation, we just move the 6 into this side, so that we will make the equation equal to 0. And so that we can find the w value. So it's like, oh, when it's a situation, what's the w value when 2w plus w squared equals 6? Well, that's so complicated, so I'm just going to move it over to the other side. So I can find the w value when the whole equation equals 0. Because then we can use a zero product property. So here is this solution. It's quite simple. It's like the same way that we did. They use x instead of a w, and then they did use a quadratic formula to get the value. So yeah, zero product property comes really handy whenever you try to solve for the value of a variable. So hope you guys enjoyed the video and have a better understanding of quadratic function and zero product. Thanks for watching. Bye.